Now, in this section, we want to talk about quadratics in particular, which is a type of polynomial. And we want to talk about vertex form versus standard form. So for a quadratic function, we have the vertex form is f of x is equal to a times x minus h squared plus k. And then we have our standard form, which is f of x is equal to ax squared plus bx plus c. So we've used the standard form when we were solving quadratic equations and doing different things like that. One thing that is worth noting, the a in standard and vertex form is the same. And we will use that. Okay, so you might be wondering, well, why do we want vertex form? Well, if we look at vertex form specifically, this is exactly in the form of our parent function when we did function shifting. So in terms of our translations, shifting, and so forth, in vertex form, A stretches or shrinks the graph. H is the horizontal shift. And K is the vertical translation. So if we have a graph or a function that is in vertex form, we know immediately what its graph looks like because we know where its vertex is going to be located. So if we think about our generic parabola, the parent function always looks like this and goes through 0, 0. That's where our vertex is, right? Well, if h and k are our shifts, in general form, it's going to shift it right or left and then up or down k. We're going to get a new parabola with its vertex at h, comma, k. So when we have something in vertex form, which is a times x minus h squared plus k, we can read the vertex directly off the graph. This is similar to the idea if we have y equals mx plus b, we can just read the slope right off the function itself, right? You don't have to do any work. You just read it off. When we have a parabola or a quadratic in vertex form, we can just read its vertex directly off. Its vertex is at the point h, comma, k. There's a few other things that will be helpful. So when we look at our parabola, we're going to have the following that is true. So 1, the vertex, as we just said, is at h, comma, k. Our graph was symmetric around its vertex. So if we shifted its vertex to h, comma, k, it's going to have a vertical line of symmetry that runs through the vertex. So then the axis of symmetry is the vertical line x equals to h. If a is greater than 0, the graph opens up and has a minimum at the vertex. So in terms of an ordered pair, it says f of h is equal to k. So k is going to be the min output, and h is the x location of the min. So when you input h, you get out k. Well, h is where the min is at, and k is the min. If our a value is less than 0, then the graph opens down, and has a max at the vertex hk. So once again, it's going to be f of h is equal to k, and this is going to be our location, and the k is the max value. So in terms of a picture, if our a is positive, this tells us that our graph opens up, so our graph is going to be happy, and as we just saw above, it's going to have a min at its vertex. If our a is less than 0, our graph is going to be sad, because it's negative, and it's going to open down. And in that case, it's going to have a max at its vertex. I know it's stupid cheesy, but it will help you remember if your graph has a max or a min, or if it opens up or if it opens down. So the sign of a determines whether it opens up or down, and that's going to give us a max or a min. All right. So now we see that vertex form is really awesome. So that should raise the question then, well, how can I find the vertex? Well, that's a good question. So if we have a function in standard form, so f of x equals ax squared plus bx plus c, we're going to draw a picture just to help us out. So I have some parabola. I'm going to assume that it opens up. The same thing would work if it opens down. So if I were to have a parabola, it would look something like this. The point that I am looking for is the vertex. And by definition, the vertex is located at the point h, comma, k. We also know that the line x equals h is the axis of symmetry. Well, that means that if we fold the graph over the axis of symmetry, it's the same on both sides. Well, that's going to be very helpful, because then that means the distance from here to here and the distance from here to here must be the same because of symmetry. Well, then that means the vertex is at the midpoint of the x-intercepts. Well, how could we find the x-intercepts of ax squared plus bx plus c? Well, we don't know what a, b, and c are, right? Oh, we already solved this problem. In fact, we solved it for every a, b, and c. It was called the quadratic formula. So we know specifically that this point is going to be x is equal to negative b plus the square root of b squared minus 4ac, all divided by 2a. And we know that this point is going to be very similar. X equals, it's going to be negative b minus the square root of b squared minus 4ac all over 2a. And if we want to find the midpoint, or the number halfway in between two other numbers, what do? We add it up and we divide by 2. So that tells us that h is going to be equal to negative b plus the square root of b squared minus 4ac all over 2a plus negative b minus the square root of b squared minus 4ac all over 2a, all divided by 2. So some really nice stuff happens. I have a common denominator already. I have a positive square root of b squared minus 4ac, and I have a negative square root of b squared minus 4ac. So those add to 0. And then I have my common denominator, so negative b plus negative b is negative 2b over 2a all over 2, and I'll write 2 as a fraction. So those 2's reduce out. And if I have a fraction divided by a fraction, I multiply by the reciprocal. So I have negative b over a times 1 over 2. So then finally I get h is equal to negative b. So negative b times 1 is negative b, all over a times 2 is 2a. So we have that the vertex is located at h equals negative b over 2a. K is then the corresponding output, f of negative b over 2a. So to find the vertex of f of x equals ax squared plus bx plus c, we have h is equal to negative b over 2a, and k is equal to f evaluated at negative b over 2a. So this guy right here is called the vertex formula. Well, let's go ahead and use that to do example number 1. So for f of x equals x squared minus 2x take away 8, we want to find the vertex, b, find the axis of symmetry, c, determine if there's a max or a min value, and find that value, and d, graph the function. So we're going to identify our a, which is 1, our b is negative 2, and our c is negative 8. So then h is equal to negative b, so negative negative 2, all over 2 times 1. So that gives me a negative negative is positive, 2 over 2, which is 1. So our vertex has x coordinate 1, and then k is equal to f of h. Well, in this case, that's f of 1. So it's going to be 1 squared minus 2 times 1 take away 8. So that gives me that k equals 1 minus 2 take away 8. So that's going to be negative 9. So my vertex is at the point h comma k, which is 1 and negative 9. So the axis of symmetry is going to be x equals h, and we just found h, so it's x equals 1. We then, for part C, we look at our a value. Our a equals 1, which is bigger than 0. So that means our graph is going to be happy. It opens up, so it's going to have a min, and the min is at the vertex. So we're going to have our f of 1 is equal to negative 9. So the min value is 9. So finally, we can then draw a graph. So our vertex is at 1, 9. Our a value is 1, so there's no stretching. So we go up 1 over 1, and we get a parabola that looks something like this. So the vertex formula allows us to find the vertex, and then the rest of the questions are really just about answering some questions about the vertex. All right, so to resolve this, once again we identify a, b, and c. So our a is 1, our b is -6, and our c is 3. So our h is negative b, so negative 6 all over 2a. So that's going to be 6 over 2, which gives us 3. And our k is f of 3. So that's going to be 3 squared minus 6 times 3 plus 3. So that gives us 9 minus 18 plus 3. And we'll get -6. So the vertex is at h comma k, where h is 3 and k is -6. So then the axis of symmetry is always just x equals h, and since we found h, it's going to be x equals 3. C, we want to know if there's a max or a min, so we analyze a equals 1, which is bigger than 0. So that tells us our graph is going to be happy, so it's going to open up. So our graph is going to have a min, and the min is always at the vertex, so it's going to be f of 3 equals -6. So that's the min value, and the min value is at x equals 3. So our minimum value occurs when x equals 3. The minimum value is the output, which is -6. And then lastly, we want to graph this thing. So we go to 3 and -6. And we know it opens up. So that was just terrible. You get something that looks like this. All right, so in these first two examples, we did these rough sketches, and all we really did was find the vertex and then determine whether it opens up or down. It turns out, as we know, A gives us a little bit more information. So the coefficient A tells us about the stretch. Factor. So our parent function, y equals x squared, is a parabola with vertex at 0, 0. And if I put in positive 1 or negative 1, I also get 1. So our unstretched parabola, to get the 3 points we need to plot it, we went over 1 and we went up 1. The A is our stretch factor. So then the graph of y equals a times x squared is going to be the same thing, but instead of containing the point 1, 1 and 1, 1 like what we had here, our stretched graph is going to have 1 and negative 1, but we're going to go up to A. So we'll get our 3 points this time, but instead of being over 1, up 1, it's going to be over 1, up A, and left 1, up A. So the stretch factor of A is going to change our graph when we go to find our 3 points around the vertex, by instead of going over 1 up 1 or over 1 down 1 if it's negative, we're going to go over 1 up A or over 1 and down A in each direction. And that'll give us the 3 points by which to plot our parabola. So let's go ahead and do that in example number 2. So we wish to graph this parabola. So immediately when we look at it, we know where our vertex is. Our vertex, h comma k, is going to be located at, and we have to be a little careful, at a times x minus h squared plus k. In our formula here, we have negative h is equal to negative 4, because we have a minus sign in our formula. So when we divide by minus 1, divide by minus 1, this tells us that h is equal to positive 4. The k does not have a minus sign, so it will be just exactly what it says there, 6. So then our vertex is located at the point 4, 6. So we go to 4, 6. We then check out our a value, and we get that our a is equal to negative 3. Well, negative says our graph is sad and it's going to open down, so I go over 1, but instead of going down 1, I'm going to go down 3. So over 1 down 3, left 1 down 3, which is a, and then I do the same thing, which is a, and then I connect my points, and that gives me my parabola. So the a value allows us to find 2 other points besides the vertex, and then we just draw a parabola that connects those 3 points. We also have to be careful because of the minus sign in the formula involving h. So our vertex form tells us what the opposite of h is, so we always need to flip the sign. All right, so we want to graph this, so we identify our a times x minus h squared plus k. So our a value is going to be 2, our h value is going to be negative 5, and our k value is going to be negative 2. So then our vertex is located at h comma k. So it's going to be at negative 5 and negative 2. And our a value equals 2, so that means our graph is going to be happy, so it's going to open up. And we're going to have a min at our vertex, which is negative 5, negative 2. All right, so we go to negative 5 and down to negative 2. And then our a value is positive 2, so I go over 1 up 2. Left 1 up 2, and then I connect the dots, and I get a parabola that looks something like this. All right, so for example 3, it says if f of x is equal to negative 16x squared plus 48x plus 2, find the vertex, find the max or the min value, the range, the intervals of increasing and decreasing, and the x-intercepts. All right, so the first thing we need is the vertex. To find the vertex, I need to know a, b, and c. So my a is negative 16. My b is 48, and my c is 2. So then h is negative b over 2a, so that's negative 48 divided by 2 times negative 16. So that's negative 48 divided by negative 32. 48 and 32 are both divisible by 16, and a negative divided by a negative is a positive. So 16 goes into 48 3 times, and 16 goes into 32 2 times. So 48 over 32 reduces to 3 halves. To find k, we put k back in, or h back into f. So we have f of 3 over 2 is going to be negative 16 times 3 over 2 squared plus 48 times 3 over 2 plus 2. So that's negative 16 times 9 over 4 plus 48 times 3 over 2 plus 2. So then 4 goes into 16, leaving 4 behind. 2 goes into 48, leaving 24 behind. So that gives us negative 4 times 9 is negative 36. 24 times 3 is 72 plus 2. So negative 36 plus 72 is 36 plus 2 is 38. So then our vertex is located at the point 3 over 2, comma, 38. So now that we found the vertex, we analyze our A. So A is negative 16. So that means our graph is sad. So it's going to open down. A is less than 0. So in terms of our graph then, it's going to have a max. And the max is going to be located at the vertex. Okay, we don't need it, but I'm going to draw myself a quick sketch to help me answer the rest of the questions. So my vertex is at 3 over 2, 38. So notice I'm not drawing this to scale, I just want a quick sketch. I know it opens down and it does this. So I'm going to have my max at that point, which is 3 over 2 and 38. The reason I wanted this is it helps me answer the rest of the questions. Well, I want the range. The range is going to be the smallest y to the largest y. So my smallest y is negative infinity. And what is my largest y value going to be? Well, that's the output of the maximum. So it's going to be 38. So my range is negative infinity to 38. And now we want the intervals of increasing and decreasing. So remember, our graph will always change from increasing to decreasing at a maximum. Well, we know where our max is. So it increases until it gets to its max. So it's going to go from negative infinity to where its max value is, which is 3 over 2. So our graph increases to its max, and then after its max, it's going to change from increasing to decreasing. So then it's going to decrease from where its max was at, 3 over 2, to positive infinity. Finally, the last thing we want to find is the x-intercepts. So remember, x-intercepts are the same as the zeros, the same as the solutions. So I need to solve f of x equals 0. So to find our zeros, we solve f of x is equal to 0. So in this case, that's going to be negative 16x squared plus 48x plus 2 is equal to 0. So the easiest way to resolve this is just going to be the quadratic formula, right? So we have a is negative 16, b is 48, and c is 2. And our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So let's just go ahead and put this into our calculator. So my a is negative 16, so negative 16, I'll store that as a. 48, I'm going to store that as b. And 2, I'm going to store that as c. So then in my quadratic formula, I'm going to go alpha y equals, grab my fraction, I go negative b, I'll do the positive one first, plus the square root of b squared minus 4 times a times c, oops, times a times c, all over 2 times a. And I press enter, and it gives me one answer. And then I don't want to have to type that all again, so I press second and enter, and it will pull up what I typed on the previous line, and then I can just use my back arrow to go change the plus to a minus for the plus or minus in the quadratic formula. Press enter, and this gives me my two values. So my two zeros, or two solutions, or my two x-intercepts are negative 0.411 and 3.04. So if I draw a quick sketch, not to scale once again, there's 3 over 2, so then 3 would be about here. I have my zeros, and then at 3 over 2 and 38, I believe that's what we found was 38, yeah. So, wow, that's terrible. Sure. We get a parabola that looks something like this, right? All right. So, as it turns out, this problem is actually the same as the one that we just did up here. So then the answer to part A is going to be h, which was 3 over 2, and our time this time is in seconds. So most people don't say 3 over 2 seconds, so we would say 1.5 seconds. What is the maximum height of the ball? Well, that's going to be k, and k was 38, and our output was measured in feet. So this says that the ball will reach its maximum height after 1.5 seconds. The maximum height that the ball reached was 38 feet above the ground. So when does the ball hit the ground for the first time? Well, that's going to be the zeros. And when we resolved it, we actually got 2 zeros. So if you imagine our ball going up and then coming back down, the first time it hits the ground is going to be this 0, so about 3.04 seconds. Well, that should make sense because we know parabolas are symmetric around their vertex. Well, how long did it take the ball to go from 2 feet to its maximum height of 38? Well, the distance from here to here is 1.5 seconds. So then the time for it to get back to 2 feet above the ground would also be 1.5 seconds, which would be 3 seconds. So then to fall the last 2 feet, how long did it take? 0.04 seconds, right? Because we know parabolas are symmetric about their vertex. All right.